Assalamualaikum warahmatullahi wabarakatuh. Saya Muhammad Hafizul Adham dan Zulkifi, Matematik 13 DEE20023. Kebetulan saya Muhammad Danial bin Tahir 13 DEE20023 dan Cikgu Nadimie Muzzammil bin Cikgu Adnan, Matematik 13 DEE20010. Ini kami akan meletakkan DEE200 subjek semiconductor kod DEE20023. Lecture Encik Jasir bin Adnan. Topik 4, Field Effect Transistor atau sekatan FET. Introduction. The field effect transistor is a three-terminal voltage controller device used in amplification and switching application. The difference between the two types of transistor is BJT transistor is a current control device. JFET transistor is a voltage control device. Two types of FET. Number 1, junction field effect transistor, in bracket JFET. Number 2, metal oxide semiconductor field effect transistor, in bracket MOSFET. JFET. JFET is a three-terminal device with one terminal capable of controlling the current between the other two. The terminal of a JFET are the source, gate, and drain. A JFET can be either P-channel or N-channel. The difference between N-channel and P-channel are voltage polarities, current direction. JFET characteristics and parameters. Let's first take a look at the effect with a VGS of 0 voltage. This is produced by shorting the gate or source junction. Example, A JFET with VGS equals 0 voltage and a variable VDS or VDD. MOSFET. The metal oxide semiconductor field effect transistor is a transistor used for amplifying or switching electronic signal. In MOSFET, a voltage on the oxide insulate electron can include a conducting channel between the two other contacts called source and drain. The channel can be of N-type or P-type, called N-MOSFET or P-MOSFET, also commonly NMOS and PMOS. MOSFET is further broken down into depletion and enrichment types, NMOS and PMOS. NMOS, N-channel MOSFET, are smaller than P-channel MOSFET and producing only one type of MOSFET, and a silicon subscriber is captured and technically simpler. P-MOSFET, P-type logic gate, and other digital circuits.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Danial bin Tahir. Okay, the next one is the MOSFET. The MOSFET have similar characteristics to those of a JFET between cut-off and saturation at IDSS. Additional feature of characteristic that extend into the region of opposite polarity for VGS. A slab of P-type material is formed from a silicon base and is referred to as the substrate. It is the foundation upon which the device will be constructed. The MOSFET operation. Zero bias. The gate is shorted to the source, so drain current equal the IPSS rating of the component. Depletion mode. The negative gate source voltage forces free electron away from the gate, forming a depletion layer that cuts into the channel. As a result, ID smaller than IDSS. Enhancement mode. The positive gate source voltage attracts free electrons in the substrate toward the channel while driving valence band hole in the substrate away from the channel. As a result, the material to the right of the channel effectively becomes N-type material. JFET amplifier. JFET can be used to make single-stage Class A amplifier circuit with the JFET common source amplifier. The main advantage JFET amplifier have over BJT amplifier is their high input impedance, which is controlled by the gate biasing resistive network formed by resistor. There you can see the equation for JFET amplifier. JFET amplifier configuration. The first one is common source amplifier. Second one is common drain amplifier. And the last one is common gate amplifier. Common source amplifier. The common source amplifier may be viewed as a transconductance amplifier or as a voltage amplifier. As a transconductance amplifier, the input voltage is seen as modulating the current going to the load. As a voltage amplifier, input voltage modulates the amount of current flowing through the FET, changing the voltage across the output resistance according to Ohm's law. Common drain amplifier, also known as source follower, typically used as a voltage buffer. In this circuit, the gate terminal of transistor serves as the input, the source is the output, and the drain is common to both input and output. In addition, this circuit is used to transform impedance. For example, the Thevenin resistance of combination of a voltage follower driven by a voltage source with high Thevenin resistance is reduced to only the output resistance of the voltage follower. A small resistance that resistance reduction makes the combination a more ideal voltage source. Common gate amplifier, typically used as current buffer or voltage amplifier. In this circuit, the source terminal of the transistor serves as the input, the drain is the output, and the gate is common to both. This configuration is used less often than the common source of source follower, usually used in CMOS RF receiver for ease of impedance matching and potentially has lower noise. MOSFET as switch. MOSFET switch use the MOSFET channel as a low on resistance switch to pass analog signal when on, and as a high impedance when off. In this application, the drain and source of MOSFET exchange place depending on the voltage of each electrode compared to that of the gate. For a simple MOSFET without an integrated diode, the source is the more negative side for N NMOS or the more positive side for PMOS. You can see the example for open switch and closed switch MOSFET in the slide.
Assalamualaikum warahmatullahi wabarakatuh. My name is Cik Nadimie Muzzammil bin Cik Adnan. My metric number is 13DEP20F1010. Today I'm going to talk about topic 5, Introduction to Other Electronic Device. First is I'm going to talk about other electronic device. As SCR silicon control rectifier, DIAC diode for alternating current, triode for all alternating current, UJT unijunction transistor. Second is silicon control rectifier SCR. NSCR consists of 4 layers of alternating P and N type semiconductor material. As the terminology indicates, the SCR is a rectifier construct of silicon material with a third terminal for control purpose. Silicon was chosen because of its high temperature and power capabilities. This is an example of physical structure and schematic symbol. And this is SCR characteristic example. Next is I'm going to talk about SCR characteristic. First, it is semi-control device. The device is turned on by applying a short pulse across the gate and cathode. Once the device turns on, the gate loses its control to turn off of the device. The turn off is achieved by applying a reverse voltage across the anode and cathode. Holding current IH is the value of current which the SCR switch from the conduction state to the forward blocking region under state conduction. Second is SCR mode of operation. In the normal off state, the device restricts current to the leakage current. When the gate to cathode voltage exceeds a certain threshold, the device turns on and conduct current. The device will remain in the on state even after gate is removed so long as current through the device remain above the holding current. SCR application mainly used in device where the control of high power possibility com with high voltage in demand. Suitable for use in medium high voltage AC power control applications such as lamp, dimming, regulator and motor control. SCR and similar devices are used for rectification of high power AC in high voltage direct current power transmission. Diode. The diode or diode for alternating current is a diode that conduct current only after its reover. Voltage has been reached momentarily. The diode is basically a two-terminal parallel inverse combination of semiconductor layer that permit triggering in either direction. This is some diode schematic symbol. Diode are also called symmetrical trigger diode due to the symmetry of their characteristic curve. Because diode are bidirectional device, their terminal are not labeled as anode and cathode but as A1 and A2 or MT1 main terminal and MT2. Triode from triode for alternating current is a generalized trade name for an electronic component which can conduct current in either direction when its trigger turned on. The triode is fundamentally a diode with a gate terminal for controlling the turn-on condition of the bilateral device in either direction. For either direction, the gate current can control the action of the device in manner very similar to the demonstrated for a SCR. Triode schematic symbol at the right. And the last one is UJT application. The most important application of UJT or puts is to trigger the resistor, SCR, triode, and other. DC voltage can be used to control a UJT circuit such that the operate increase with an increase in DC control voltage. This application is important for large AC current control. UJT can also be used to measure magnetic flux.